All right, 13. I'm thinking, so I'm just going to work through these with my thought process, and then if somebody had a different solution, I'd love to hear about it. When I see this, I kind of feel like this left-hand side is more complicated, so I'd probably start there. This is homework. This is from page 460. Got subtraction in it and it's squared. I'm feel like that one. For me, that one looks more complicated. So I started there. And then I would probably just square this binomial. Now that's not 1 squared plus tangent squared. Remember when we square a binomial, do you all remember the shortcut for squaring binomials? We're going to need this a bunch in this chapter. A plus B quantity squared is equal to A squared plus 2AB plus B squared. Do you all remember that one? And if this is a minus, then this changes into a minus also. So this is a minus, so it would be 1 squared minus 2 times 1 times tangent, which is just 2 tangent, plus, and then tangent squared. So that's probably where I would start. That would be my first move. And I'm wondering if we got a Pythagorean identity we can use here with this tangent squared. Oh yeah. Turns out that 1 plus tangent squared is equal to secant squared. So that's a 2-stepper. I would consider a really common mistake though for someone to see this 2 here and think you can just square this stuff in here, which is true as long as you include that middle term also. All right, what else? 16. I think someone asked about 16. Was that right? Or was it 18? 18. 18. Did you start on the other side when you tried 13? Yeah, it would be considerably tougher to start on this side. So that's a good example. If you got stuck on one side, try starting with the other side, because sometimes it's way easier from the other side. Secant squared theta minus 1 over sine theta. Why do they keep changing the variables? It's kind of annoying. Okay, which side looks more complicated? This one has a subtraction in the denominator and looks more complicated, so I would probably start with that. 1 minus sine squared is cosine squared. I'm also kind of thinking a step ahead. I don't know. I'm not, because now I'm starting, because if I think about this and I'm like, if my first move is going to be to turn 1 minus sine squared into cosine squared, this gets pretty simple. And then now this is looking like the more complicated one. So I think I would probably start with the left. Are you guys getting to the point where you're seeing like 1 minus sine squared or 1 minus cosine squared and thinking one of those Pythagorean triples? I think I'm going to start with the left. Secant squared minus 1 over sine. Secant squared minus 1. That is one of our identities, isn't it? That is tangent squared. So secant squared minus 1 turns into tangent squared. Gee, how am I going to turn? Where am I going to get that 1 minus thing from? Well, let's just keep going and see what we can do. I'm thinking about turning this into all sines and cosines to see what happens there. So tangent squared becomes sine squared over cosine squared. And instead of dividing by sine, I'm going to multiply by the reciprocal of sine. Are we okay with that first step? Remember that trick I showed you, that instead of having this as a dividing by sine, you can multiply it by 1 over sine. I think I'm seeing where this is going to go now. Sines are going to cancel here. We have cosine squared left. And then cosine squared is 1 minus sine squared. And then we end up back here. Okay. Yeah, I think if I had started with this, I think I probably would have hit a dead end pretty quickly and ended up trying the other side. If you start here, because then you end up with sine over cosine square, which is tangent times 1 over sine. Tangent turns into, yeah, I guess that would work. Tangent turns into secant squared minus 1. Could have done it that way too. Cool. What else? What others do you guys want to talk about from homework? Do you feel pretty successful on this? Oh, okay. If not, then let's talk about a couple. I mean, I don't have time to do the whole thing, obviously, but 15, yeah. Thank you. Ooh, 15 looks kind of messy. I'm going to use X's instead of U's. Are you okay with that? Well, the decision which side to start on is pretty clear on this one. This is way more complicated than this. Yeah, so I think I'd start on that left-hand side. And then I've kind of got two ideas here. In the numerator, I could multiply this out. It is a difference of squares, so we could kind of use a shortcut to multiply this out. My other option would be to turn cosine squared into 1 minus sine squared. But I'm looking at this, I don't have any addition or subtraction over here, so I don't think I want to start introducing more addition and subtraction than I already have here. So I think I'm going to go with the numerator, multiplying that out. So that's like that a minus b, a plus b, which is a squared. So 1 squared minus b squared, which would be cosine squared x over cosine squared x. I could split this up into two fractions. Is that going to help me? Well, this is sine squared. 1 minus cosine squared is sine squared. Oh, and then we'd end up with sine squared over cosine squared to get, so yeah. So I think that's probably the quickest path is 1 minus cosine squared is sine squared. So I got sine squared over cosine squared, and that's tangent squared. That gets us there. Any others? Yeah, thanks for asking. Ooh, it's got some messy fractions too. I lost it. There it is. Equals 2 cosecant squared x. So as far as where to start, I think the left side looks more complicated. And as soon as I saw this problem, as soon as I started writing it down, I started thinking about common denominator. I have a feeling that this is going to be a common denominator type problem. So let me get it going here. That's my instinct. I don't know for sure that that's going to give us what we want, but let's try it. So left-hand side, and then I need to throw some fancy ones in here to get a common denominator. All right, so this one's got a 1 minus cosine x. This one has a 1 plus cosine x. So we're going to need basically the other one in each of these. I'm going to need a 1 plus cosine x here. So I'll make my fancy version of 1 with 1 plus cosine x there. This one's missing the 1 minus cosine x, so I'll make my fancy version of 1 here to have the 1 minus cosine x. So we now have a common denominator. And it's these two things multiplied together. And I'm going to go ahead and multiply them out. Again, that's that a minus b, a plus b thing. So it's going to be a squared, which is 1 minus b squared, which would be cosine squared x. And as I'm writing down, I'm already kind of having the back of my mind that this is going to Pythagorean and something else. Let's go ahead and put the top in. We've got 1. We're just multiplying by 1, so I don't really need the parentheses. 1 plus cosine x plus, and 1 times all that stuff too. So I'm leaving the parentheses out there also. And up there, I see 2, and I see those cosines going away. So do a little combining like terms on the top when we got 2. And then I haven't used any, that's not an identity, so I can do an identity on this. That is 1 minus cosine squared is sine squared. And I think that gets us there, right? 2 times 1 over sine squared would be 2 cosecant squared. Yeah. I'll leave the last step there for you guys. One more. You don't have to, but. Which one? 19. It's 19. Ooh, that one looks messy. Okay. To save myself some time here, I'm just going to jump straight into the proof instead of writing the identity down. Because that's a big old messy one. So this looks more complicated. But I'm kind of, oof. I'm wondering if you multiply this out, if that's going to get you pretty close, because I can see the 1 coming out of that. Oh, does it? You just do FOIL on it? Multiply out left side. Let's try it. So we got betas in here. We're going to see betas today, so. So yeah, if you do FOIL on this, first times first would be 1. Outside times outside would be cosecant b, beta rather. Inner times inner would be 1 times negative, so that's negative sine beta. And last times last would be, it's going to be negative, and then sine and cosecant. Sine beta. Was it cosecant? Yeah. And that's exactly what they wanted. Huh. Well, I've got these two things flipped around, but that's a weird one though, isn't it? Like, it seems like there should be more than that to it. But yeah, it's a one-stepper. Well, we're just doing FOIL. Right? First times first is 1. O stands for outer, so outer times outer. 1 times cosecant b is 1 cosecant b. Inner times inner, that's the I in FOIL, would be negative sine beta, and then last times last will give you that. So we're doing FOIL. Some of your teachers might have taught you to do this instead. This is like a, sort of a visual representation of FOIL. Does that look more familiar to you? Miss Castleberry does it that way. Mr. Skaggs does it that way. Way back, and like in a lot of our Algebra 1 classes, we do this thing with the box. You could do it that way. It gets kind of messy when you start putting sines and cosecants in there, but yeah, we're just multiplying out those two binomials. All right, let's get into the new stuff. I need to pass her out, or can someone pass her out some papers for me? Please, please, pretty please. Thanks, Caleb, you're awesome. I have conscripted you.